Alright, so here we go. We're going to review for the quiz. Right in front of your screen, this is a formula chart of everything that involves Unit 11. So I'm just going to scroll down, and then if you need to pause, you can do so. But once I hit the end of the reference chart, most likely you won't get this on the quiz, but this is just going to be a resource for you while you are studying for, the upcoming quizzes and tests. Here we go. Quiz 11.1, which will go over lessons 11.1 and 11.2. I have a parallelogram. I'm going to find the area and the perimeter of this figure. So, since this is a parallelogram, it's important to know that opposite sides are congruent and opposite sides are parallel, but I'm not going to mark the parallel sides. We know that with the parallelogram, the opposite sides are parallel. So, this is 20 feet, that's 20 feet. That's 18 feet, that's 18 feet. So to find the perimeter, I really do need to get my calculator out. 1 second. So to find the perimeter, I'm just adding up all the sides here. I have 2 20s plus 2 18s. So I do 2 times 20 plus 2 times 18, and that's going to give me 76 feet. And then to find the area, well, the area formula for a parallelogram is A equals base times height. So what's the base and what's the height? Those two segments must be perpendicular to each other. So this is the base and that's the height. This is not the height. That's the slant height. You want to figure out which segment is perpendicular to another segment. So 18 and 16 are perpendicular to each other, so I write 18 times 16. So 18 times 16 is 288 feet squared. Okay, so those are your two answers. This right here, it says find the amount of material needed to make one side of Brianna's tote, which looks like a trapezoid. So this looks like a trapezoid. The formula that you need to know when it comes to finding the area of a trapezoid is 1/2 of the sum of the two bases multiplied by the height. With the trapezoid, remember that it has one pair of parallel sides. So this is parallel to that side. So that means that since this side is parallel to this side, then these two numbers here, or those two sides there, are our bases. So we can call this base 1, base 2, and what is the height? Well, the height is always perpendicular to the two bases. So let's plug them in. That's equal to 1/2 of 28 plus 58 times the height, which is 30. And if I were to put this in my calculator, you can type it in just like this. 1 divided by 2 times 28 plus 58 times 30. Just like that. 1,290 centimeters squared. Okay, so the next thing is, let's take a look at this example here. It says, find the area of the glass used to make the windshield. The windshield itself looks like a trapezoid. So again, it has one pair of parallel sides. So let's use our formula. The area is 1/2 of B1 plus B2 times the height. That is equal to 1/2 of 72 plus 85 times 35. And then I'm going to rewrite this as 1 divided by 2 times 72 plus 85 times 35. Put that in my calculator. Or what you can do is you can do this. You can put this into your calculator, and whatever that is, you divide that by 2. Okay? So that is, what's the answer? So 1 divided by 2. Oh, I made a mistake here. This is 38, and I put 35. So I'm gonna change that. Okay, so that is 2,983 inches squared. Alrighty, here we go. Next one. And I do encourage you to get a separate sheet of paper and work through these problems with me. Just by watching the video, that is not going to be helpful for a lot of people. So doing the problems is just helping you study and being better with the material. So I highly encourage that you practice along with me than just watching the video. Alright, so I got these two figures here. I gotta find the area and the perimeter each. This should be perimeter, by the way, I don't need to find the area twice. Alright, let's figure out this problem here. So assume that this figure is a parallelogram. So that means that the opposite sides are congruent. So if this side is 12, then that side is 12 centimeters. If this side is 20, that side is 20. So then I can do 2 times 12 plus 2 times 20. And that's going to be 64 centimeters. 64 centimeters. And the area is base times height. So remember, the base and the height, they are perpendicular to each other. Okay, so I'm just looking. Okay, well, I have the base here, and then here's the height. I know that those two segments are perpendicular because they intersect at a right angle. But we don't actually know what the height here is, and that is where we're going to have to apply. Well, you probably guessed it because you see the 60 over here, and also since these two segments intersect at a 90-degree angle, I have to draw this square here to show that that's a right angle. We have 60, we have 90, and the sum of the interior angles of a triangle is 180, so this is our 30-degree angle here. So applying special right triangles, hopefully you remember how to do special rights. So let's go ahead and say, okay, across from 30 degrees, this side is A, and across from 60 degrees, this is a root 3. But I only need this side here because I already found the perimeter, I don't need to figure out what this is, or the side here is. It's 20. That's great. So note that our A is given, or not given. We know what it is. It's 12. So if A is 12, then this height here is 12 root 3. Okay. So our base is 12, and our height is 12 root 3. So I can go ahead and plug them in. So the base is 12, and the height is 12 root 3. I will multiply the coefficient to coefficient and radicand to radicand, but there is no radical here. So I just do 12 times 12. So 12 times 12 is 144, and then I'm going to slap on that root 3. So your area is 144 root 3 centimeters squared. And we square this because we are dealing with area. Alright, Now let's take a look at this example here. Okay, you know, I'm not gonna lie, I wish that this one is a 45, 45, 90. So let me real quickly find one where we use a 45, 45, 90. Let's see. Here's a 45, 45, 90 scenario. How do I know? Well, of course, this is the base, this is the height, they intersect at a 90-degree angle, so I'm going to draw that 90-degree angle, or that, you know, square. This is 45, this is 90, and of course this is 45. So then, across from 45, I set 9 equal to A. Across from 45 degrees here, I will set that side, I'm going to set that side equal to A. And across from the 90-degree angle, this side here is going to be A root 2. Okay, so that side is A root 2. Note that A is equal to 9. So if A is equal to 9, that means that this height here is 9. And then this side here will be 9 root 2. And I know for this example it says only to find the area of these two problems on the notes. I'm going to do something different. I'm going to find the area, and I'm going to find the perimeter. Okay, this is 9 root 2. This does look like an A that I had before, but to clarify, that's a 9. Alright, so this is a parallelogram. We can assume so because it says right here. And since it's a parallelogram, remember, opposite sides are congruent. So if this side here is 17, that means that this side here is 17. And if this side here is 9 root 2, then that side is also 9 root 2. So what do? Well, I'm going to add up all the sides. You should get, you have 2 17s plus 2 9 root 2s, right? Because I'm basically saying 17 plus 17 plus 9 root 2 plus 9 root 2. This is, what is that? That's 34 plus, and then 2 times 9 is 18 root 2. This is weird because if you want to leave your answer in radical form, that's just going to be a lot of work. But what I want to do is type these two numbers into my calculator, add them, and I should get a decimal. So I have 34 plus 18 root 2, and you will get, let's round to the nearest tenth here, you will get P, which is the perimeter, is approximately 59.5. Okay, that's the perimeter of this figure. But to find the area, it's simple. It's base times height. The area is equal to 17. That's the base, and that's the height. So 17 times 9. That's 153. 153 square yards. And this over here, the units, or the unit, will be 59.5 yards. Alright, let's go back to the document, to the review itself, and then we can just forget about this problem here because I did one with a 30, 60, 90, and I did one with a 45, 45, 90. This you can just do on your own if you wish. I took that from, I believe, the 11.1 note, so you can go ahead and refer back to that if you wish. But the show must go on, so let's go ahead and take a look at our next example here. It says, find the area of the triangle with side lengths 12 meters, 16 meters, and 22 meters using Heron's formula. Heron's formula, by the way, let's write what's Heron's formula. A equals the square root of the semi-perimeter times the semi-perimeter minus a side length times the quantity semi-perimeter minus another side length times the quantity semi-perimeter minus another side length. So A, B, and C represent the side lengths, and all the S's that you see right now, that's where you plug in the semi-perimeter. Now the semi-perimeter is equal to all the side lengths divided by 2. You're adding all the sides of that triangle and then divide by 2. You use harons, by the way. It's so important you understand. You use harons when there is no given height of a triangle. Like this example here. You're given the side lengths of this triangle, but you don't see the number or the height anywhere. So you gotta use this formula. Alright, well, let's go ahead and figure this out. I'm gonna call this side length A, call this side length B, that's C. So to figure out the semi-perimeter, I'm going to add up all the sides here. 12 plus 16 plus 22 all over 2. 12 plus 16 plus 22 is 50. Then you divide that by 2. 50 divided by 2 is 25. Your semi-perimeter is 25. And since you have the semi-perimeter, you can plug everything in. You have the semi-perimeter and you have the side lengths. There's no excuses. So, alright, let's go ahead and plug them in. Here we go. Area is equal to the square root of 25 times 25 minus 12 times 25 minus 16 times 25 minus 22. And then once you reach this stage, make your life easier by plugging all of this exactly into the calculator. I'm gonna do that right now. I'm not gonna show you, but at this stage you should know how to use your graphing calculator. You should know where the square root button is. You should know where the parentheses buttons are. So plug everything in exactly into your calculator. So you take the square root, second x squared, input 25, put parentheses around 25 minus 12, and then do the same thing for 25 minus 16 and 25 minus 22. So your answer is approximately 93.67 meters squared. Don't forget, you're trying to figure out the area. Put the correct unit. Put the correct unit. Next problem, number 20. Okay, so the height of a parallelogram is 4 centimeters more than the base. If the area of the parallelogram is 45, find the base and the height. Now, we're dealing with the area of a parallelogram. So the area of the parallelogram formula is A equals base times height. Note, it says find the base and the height. That's your goal. We're working backwards, by the way, so we are working backwards. And I'm just going to... Okay, well, we know that A, or the area, is 45, so replace A with 45. And that is equal to the base. So I'm going to look around. I don't see how long the base is. All I can see is this sentence right here. The height of a parallelogram is 4 centimeters more than the base, which we don't even know what the base is. This is the only given information that I have here, but since it just says the base and it's our unknown, well, how do we represent that? Well, the base is equal to x. That's our unknown. So therefore, the height of that parallelogram, it's 4 centimeters more than the base. So essentially that's saying 4 plus x. So the base I can replace with x, And the height I can replace with 4 plus x. And make sure you're using parentheses, okay? Alright, so I have, actually I don't really need to put parentheses for the base here. So x times the quantity 4 plus x. I have an expression here, and I am going to multiply that with this binomial here. You're going to apply the distributive property. So 45 equals, well, we have 4x plus x squared. Okay, so I see 4x plus x squared. I'm just going to rewrite that as x squared plus 4x. And then, alright, I can see that I have an x squared. I can see I have a 4x here, and it's equal to some number. So that means that I'm going to have to factor in this case. So subtract both sides by 45. You should get 0 equals x squared plus 4x minus 45. And I'll rewrite that as x squared plus 4x minus 45 equals 0. Because that's just who I am. I like to have the 0 on the right hand side. Now here, this is where I'm just going to factor. Right here. I see this expression, it's a trinomial. I'm going to use the x method. Negative 45 goes up top. 4 right there, down below. What are the two numbers that multiply together that'll give me negative 45 and add up to 4? I'm thinking 9 and negative 5. 9 times negative 5, or I should say 9, there you go, times negative 5 is negative 45. 9 plus negative 5 is 4. So these two values do work. So I write x plus 9, right? Positive. Since it's a 9, it's implied that it's positive. So x plus 9 times x minus 5 equals 0. So x is equal to negative 9, x is equal to 5. You guessed it. We're going to take the positive x value. Okay? I'm not done. I got to figure out the base and the height. So if x is equal to 5, the base is going to be 5 centimeters. And if x is equal to 5, the height is 9 centimeters. And there you go. Those are your two answers. Alright, number 21. The base of a parallelogram is 4 times the height. If the area of the parallelogram is 36 square centimeters, find the base and the height. Okay, so we have the area of a parallelogram. Again, A equals BH. Area equals base times the height. And the area is actually given, so it's 36. And that's equal to, alright, what's the base and what's the height? Well, over here it says the base of a parallelogram is 4 times the height. The base of a parallelogram is 4 times the height. So, do we know what the height is? Doesn't say. So the height is going to be our unknown. And the base, it's 4 times the height. We represent that as 4x. So I'm going to start replacing. The base is 4x. So 4x. And then our height is just x. Alright, so look at the right hand side of the equation. We have 4x times x. Let's ignore the 4. What's x times x? That's x squared. Then we're going to put the 4 there. So 36 equals 4x squared. And I'm going to use a different color because if I put blue here, it's gonna be hard to read. So 36 is equal to 4x squared. I got to divide both sides by 4 here. Okay? So the 4's will cancel out. 36 divided by 4. That's 9. So 9 on the left-hand side is equal to x squared. And then this is where you're going to take the square root. So 3 is equal to x. We want the positive answer. So if you think it's plus or minus, take the positive answer. And then let's go ahead and plug 3 in. So the height is 3 centimeters. And the base is just 12 centimeters. And you can see this does, these answers do work out. The base of the parallelogram is 4 times the height. Okay? So this is 4 times this, if that makes sense. That's how you check your work. All right, this is going to be a little weird because I'm going to review some special right triangles with you. Even though we did some special right triangles, I just want to make sure that you know certain skills when you're doing special right triangles. I do not encourage you to skip this part. I am reviewing this skill with you for a reason. So here we have this figure here. We can assume that this is an isosceles right triangle. How do I know that? Well, number one, this is a right triangle, and two, these segments are congruent to each other. So that means that if those sides are congruent to each other, then the sides opposite, the angles opposite to those sides are congruent, okay? So 45 here, 45 here, 45 plus 45 is 90, 90 plus 90 is 180. We're dealing with a 45, 45, 90 triangle. All right, we know how to label, so across from 45 degrees, this is A. Across from 45 degrees, this is A. And then this one, the side here, across from the 90-degree angle, this is A root 2. We know that A is equal to 9 root 2. And I'm solving for X here. X is currently A root 2. So if I know what A is, I can just plug in whatever A is here. So this is 9 root 2 times root 2. That is 9 times, well, root 2 times root 2 is 2. Your answer is 18. Okay, C, this is an isosceles right because these two segments are congruent. They're both X's. So it's implied that this is a 45, 45, 90 triangle, or an isosceles right triangle. If I label across, let's use a different color here. Across from 45 degrees, this is A. Across from 45 degrees, this is A. And across from 90 degrees, this is going to be A root 2. All right. So X is equal to A is equal to X, 12 is equal to A root 2. What am I supposed to do here? Well, I need to get this by itself. So I'm going to divide both sides by root 2. The root 2's do cancel here. So I have 12 divided by root 2, which is equal to A. And, well, I can't have a radical in the denominator whatsoever. So I have to rationalize. And we do that by multiplying the top and bottom by the radical that appears in the denominator. So I gotta multiply this by root 2, and I gotta multiply that by root 2. So we multiply across. So what do I have? I have 12 times root 2, which is 12 root 2, all over root 2 times root 2, which is just 2. And that's equal to A right now. But note that we can simplify this. 12 divided by 2, that's 6. So 6 root 2 is equal to A. And then I can just plug this into that A over there. So X is equal to 6 root 2. So X equals 6 root 2. All right, let's take a look at this one right here. This is a 30, 60, 90 triangle. So label, this is A, this is A root 3, and then over here, this is just 2A. We have 12 equals A root 3. So 12 equals A root 3. I'm going to solve for A. And if you do remember the trick that I taught you Yes, I'm going to have to divide both sides by root 3 and then do all of these steps. But the trick here is, here's 12, here's root 3. What's 12 divided by 3? Well, 12 divided by 3 is 4. Then you slap on the root 3, which is going to give you your a value. For this one over here, 12 equals a root 2. Well, you do 12 divided by 2, which is 6, and then you slap on the root 2, and that gives you our answer. Okay, so a equals 4 root 3. If a is equal to 4 root 3, then x is equal to 4 root 3. 4 root 3. And then y is equal to 2 times 4 root 3, so 8 root 3 is your answer. Alright. Okay, I'm just going to throw this out here. I am going to edit this part in, but suppose that you have something like this. If you have to, and it has nothing to do with the examples we did here, but suppose that you have something like 6 root 2 divided by root 2. Well, what do you do to simplify this? Well, I have 6 times root 2 divided by root 2. It's just like saying 6 times 3 all over 3. And that's, well, 6 times 3 is 18. Divide that by 3. That's what? 6, right? So, if I look at this and ignore all of this, well, 6 times 3 divided by 3, I see there's a 3 up top, 3 down below, so I can just cancel them, and that's your answer, right? Over here, I have 6 times root 2 divided by root 2. Well, just like what we did before, I can just cancel what the top and bottom are. So, boom, I can, cancel that, and this is our answer, 6. Got some more to talk about. So here I got to figure out the area and the perimeter of the triangle, the shaded figure over here. So what do I do? Well, I'm going to figure out the area, which is really, really easy. The area of the triangle is always 1/2 base times the height. So A equals 1/2 base times the height. And note that the base is always perpendicular to the height. So here's 11, and it's perpendicular to the height, which is 25, if you can see that. Okay, so this triangle is 25 millimeters long. So A equals 1/2 of 11. Multiply that by 25. And the area is going to be, so I'm going to do 1 divided by 2 with the parentheses, multiply that by 11, multiply that by 25. You should get, A is approximately 137.5 millimeters squared. Okay? And then to find the perimeter, you have to add up all the sides here of the shaded figure. So this figure here. Okay? You got 35, you got 11, and then you have this side length, which is our unknown. So 35 millimeters plus 11 millimeters plus that unknown side. But you can see we have a right triangle. So all we gotta do is apply the Pythagorean theorem, which is a squared plus b squared equals c squared. So what's a? A is going to be 23. So 23 squared plus what's b? 25. So 25 squared. And then this is our c value. And how do we know that this is c? It's across from the 90-degree angle. Always, always. The side across from the 90-degree angle will always be your c value. In this case, we don't know, so I'm just going to leave it alone and just call it c squared. Alright, we have, this is a 23. So 23 squared is 529 plus 25 squared, that is 625, and that's equal to c squared. So I'm going to add those two numbers up. You get 1,154, which is equal to c squared. Then this is where I take the square root. You're not going to simplify the radical. This is a huge radical. I would just take the square root of it on my calculator and get that decimal. Round to the nearest tenth if necessary. So on my calculator, it has 33.97. So since I have 33.97 and I'm rounding to the nearest tenth, well, that 7 is going to dictate that 9. And then that 9, okay, because 9 is being rounded, then it's going to be a whole number now. This is now going to become 34. Okay, so C is equal to 34. So then I can replace this question mark with 34. And then we have 35 plus 11 plus 34, and our perimeter is 80 millimeters. Alright, and then, you know, when you're dealing with the Pythagorean theorem, perhaps there might be some triples that you can use instead of, you know, calculating the side length like we did over here. So if you know your triples, you know, what we were dealing with, we couldn't use a triple. We actually had to find the side length. But if you can easily spot a triple, you don't have to show those unnecessary steps because triples are known. So go ahead and just look at the triples list, memorize them if you need to, and then you should be good to go. Alright, our last 3 problems here, super simple. We're dealing with rhombi and kites. Let's see, actually I think we have 2 kites and a rhombus. But nonetheless, the formula is A equals 1/2 diagonal 1 and diagonal 2. These are the diagonals. So let's take a look at number 11 here. A equals 1/2 d1 d2. 1/2 of we gotta be careful. Slow down. This segment here is 8, but it's congruent to this segment, so that should be 8 as well. So this diagonal is actually 16 inches long. So 1/2 of 16 times 17. 1/2 of 16 is 8 times 17. That is 136 inches squared. And then number 12 is same thing. We do A equals 1/2 d1 d2. So 1/2 d1 d2, and that's equal to 1/2 of this diagonal, which is 7, and you multiply that by this diagonal. So I can see that 6 plus 9, that's 15. That's how long that diagonal is. It's 15 centimeters. So I can put 15 here. Alright, so if I put all of that in my calculator, you will get 52.5 centimeters squared. And then this one right here, number 13, 1/2 d1 d2, 1/2 of 11 times 25, so Your answer is 137.5 square feet. And there you go. That is the review for this quiz. Good luck.